past 3.3. Did you hear me talking to you? Was that Mr. O'Quinn?
Yes.
Our answer was correct. You know, the answer that I got, negative x over n or something like that, negative x over y.
Negative x over y.
It was a problem we did 3.3857. I
remember that one, yeah.
Okay. Do you remember what question that was?
No, but I have it in my notes. Hold on.
Okay. I want to pull it up because I want y'all to make a note of it because the answer is incorrect. If you'll look, they sent me a big thing that said they're changing it in the homework.
Oh, did you see the one that I sent you?
Yeah, but what number was it?
I just redid it a second ago. Hold on. It's 3.8.57. Yeah, that'd be the one that I sent you.
3.3857?
3.8.57. No, yeah, just 3.8.57.
3.857. Okay. Yeah. So I am recording. 3.857. Here you go. Okay, make a note on this one. 3.857. He did the problem and I did the problem, and we both got, I forgot, negative x over y, I think.
Right.
And the answer that you had to choose from was not negative x over y. It was like negative 1 over x squared or something.
That's it. Yeah, I'm looking at it too.
And there it is.
Section D.
So make sure that you make a note of this one. They're going to change it. I don't know when they're going to change it, but they're going to change it. For now, you click on the 1 over x squared, but that's not the right answer. It said that there was a glitch in the programming. I said, well, that's nice.
Yeah, I changed the world today.
Huh?
I said, yeah, I changed the world today.
Yep. You can only change it one question at a time. Poor old Elmer Fudd don't have a gun anymore. But the world's problems are solved by Elmer not having a gun. All right. So I got a couple of questions that were sent. Here's one. Had a couple that were sent like this one, so I'm going to do a couple of these. This is 3.544/21, and they are test questions. So that's why we're going to spend a little bit of time on it. So go ahead and write this one down. I don't know if this is the one I started off with. I don't know. I got 3 of them, I think. They're similar, but they're different. 2. I got 2 of them. Cosecant, cotangent. So they're wanting you to take the derivative. Of course, you're going to use the quotient rule, the product rule. So that's going to be R is equal to cosecant of theta, cotangent of theta. And that's going to be first times the derivative of the second plus the second times the derivative of the first. R is equal to cosecant theta. The derivative of the cotangent is negative cosecant squared. plus the cotangent times cosecant cotangent, negative. The reason I brought up Elmer Fudd is because my son came in to watch TV a while ago, and he put it on cartoons, and Elmer Fudd was playing in the background a while ago. Now,
They still show those on TV?
yeah, we have the racist channel. So,
Oh.
yeah, we get Elmer Fudd. He's racist.
I didn't know they still played, what, Is it Looney Tunes anymore?
He watches the Cartoon Network, or one of those networks that play the one of them plays the old ones.
I think it's Boomerang. I didn't know
Yeah,
that was
that's it. That's it.
Yeah, it's Boomerang.
The racist channel. He has a gun. So anyway, so we've got the now. A lot of you probably say at this point, well, how in the hell do I know what to do next? Well, there's a rule of trigonometry that everybody should know. Does anybody know what that rule is when you got something like this?
Switch it over to sine and cosine.
There you go. Mr. O'Quinn said it correctly. When in doubt, put everything in terms of what? Sine and cosine. So go ahead and do that. Change every one of those that you can into some form of sine and cosine, because that will help you out tremendously when you're dealing with trig. And I guarantee you somebody out there has never heard of that before.
I haven't.
So
I'll admit to it.
Say again?
I haven't heard of it. I'll admit to it.
Yeah. That's when you get to a point in trig. Now, I'm not talking about calculus. I mean, we're done with the calculus. We're done. Okay? So the calculus is not that part. But after the calculus, when in doubt, write everything in terms of sine and cosine. So the cosecant is 1 over the sine. Okay, now y'all be careful here. I'm fixing to use a lot of reasoning here. So the cosecant squared is 1 over the what? Look at there. Isn't that special how that works? Plus cosine over sine times negative 1 over sine. And if you didn't get that at the beginning of the problem, then hopefully you got it by now. Times cosine over sine.
You just blew my mind and made my life so much easier.
Oh, yeah.
You are kidding me. You're
Let's
kidding,
do
right?
identities while we're at it.
No, I'm not.
I mean, I submitted that question because I'm absolutely atrocious at trigonometry, and this is a rule that I didn't remember. I knew that we could swap them. I guess I don't have the path of thought to arrive at this.
Well, see, Mr. Luckner, you know, I was in the military. I was in the Marine Corps. What were you in?
Army.
Okay, you wasn't in the military, but I was. And you learn, you know, in the military, when in doubt, whip it out. You know, when you know, saluting. Well, same thing here. He can take a joke. If I can take a crayon joke, he can take a military joke. All right. So when in doubt, change everything to sine and cosine. And go ahead. I want y'all to go ahead and see if you can finish it now. Because you got something here, and you got something here to do. Oh, did I tell y'all that we were done with the calculus? Oh, yeah, we're done with the calculus.
The lack of colors gave it away.
Yeah, oh, darn. I've got y'all conditioned, haven't I? Yeah, y'all going to go into calculus 2 with, and be like Ferris Bueller. Ferris Bueller, Bueller, Ferris Bueller. Okay, so that's going to be R is equal to, or Charlie Brown's trombone teacher, was that a trombone? 1 over sine cubed theta plus, and you're going to go ahead and factor this out. I mean, you got cosine. Well, you can basically, before you do that, you do cosine theta over sine theta. And then 1 times cosine is cosine theta over sine squared theta.
Yeah, negative.
Negative. Oops. Negative. And R is equal to 1 over negative sine cubed theta. And then that's going to turn into minus cosine squared theta over sine cubed theta. Now, we could factor out a 1 over sine cubed, and watch what happens. I'm going to factor out a negative 1 over sine cubed. And that will leave you with 1 plus cosine squared theta. And then what is 1 over sine cubed?
Cosine.
Cube.
1 over sine cubed. That's cosecant. Negative cosecant.
That's what I meant.
That's all right. Cube theta. 1 plus cosine squared theta.
Yep, that just blew my mind, and I did it the hard way, and that just made it so much easier, and I'm mad I did it the hard way.
I'm sorry. Hey, at least the silver lining is the little light bulb came on. We're going to try another one. So in this problem, let's see what the answer is. Let's see, we got a negative cosecant cubed, and then 1 plus cosine, so that would be A.
Mm-hmm.
And do we feel good about ourselves? Yep.
Always.
So I don't have to put smokestacks on my pickup truck, because I feel good. All right, the other one that I got, and I didn't bring it up, let's do one very similar. Making sure I'm not getting my cross. There we go. R is equal to cosine theta, cotangent theta. All right, I'm going to let y'all work this one. Since these are 2 good test questions that I would put up for 3.5, I'm going to let y'all work them. So go ahead and work. I'm going to give you a minute.
Just
3:34. Say again.
What are we working?
Cosine. Oh, sorry, y'all can't see it. Wish I could leave that thing on all the time. There we go. There you go. Give y'all a minute or two. Give y'all another minute, because the calculus, if y'all noticed, it's not very difficult. Calculus is like 1 is 10%, and 2 is not very difficult. I'll go ahead and write the product rule out though. R prime is equal to first times the derivative of the second. I'll just write it in green. Plus the second times the derivative of the first. Well, you give me my phone, please. Now the next step is your calculus. After that, you're done with the calculus. So R prime is equal to cosine theta negative cosecant squared theta plus cotangent theta, and the derivative of the cosine is the blah 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 negative sine. Okay, there's your calculus. Now rewrite. Write everything in terms of cosine and sine. Give y'all 30 seconds to do that. Evidently, my son didn't hear me telling bring me my phone. He must have had his earplugs in. So that's going to be, let me get my black pen. R prime is equal to, cosine theta, sorry. Negative 1 over sine squared theta plus cosine theta over sine theta times negative sine theta over 1. And of course, you see that the signs go out.
It's all the cofunction.
What?
Nothing at the end, I'll explain.
Are you talking to yourself again?
Something like that.
Okay. So that's going to be R prime. Do you answer yourself? Cosine theta over negative cosine over sine squared theta minus cosine theta. You can factor out a negative cosine. And that's going to give you 1 over sine theta. I'm sorry, 1 over sine minus 1. And that's cosecant minus cosine theta. And that's cosecant squared.
There should be a +1.
Yeah, because you
I must have dropped. Oh, there. I dropped one somewhere.
No, when you took out the negative cosine.
Oh, yeah, right here.
Positive one.
Right there. Thank you. Thank you, whoever first said it. Thank you. That should be your answer. Yeah, that's the answer. And like I said, I had 2 homework questions like that. One was emailed to me. They didn't send it to ask my instructor, so those don't register because I don't do those. I'll tell you why. I don't tell many students this. My second semester teaching, we didn't have computers back then, and a student came in, and I was second semester, really nervous teaching in front of a whole classroom of students, and this student brought a problem that she couldn't do. And I said, what is the problem? And she told it to me, and I put it on the board. That was an hour and a half class. I worked that problem 7 times, and I never could get the answer. So I said, I must be missing something. So I turned in the book where she was, where she got it from, because back then we didn't have the computer homework. And guess what? Anybody want to guess?
She wrote it down wrong.
She wrote the problem down wrong. So that's why I was getting the answer wrong. Of course, I had four or five bubbas in the back of the room telling everybody I didn't know what I was doing because I kept getting the wrong answer. But the fact was, I was doing a different problem because she wrote the problem down wrong. So that's why I don't like, and now that we've got computers, I either want a printout of the problem or I want you to send it to me with Ask My Instructor. And if you send it to me with email and type it in, okay, that's funny in itself because all you got to do is hit Ask My Instructor. But anyway, I'm not going to take it.
So I can't see the problem on the WebAssign or whatever it is, My Labs. I can't see it very well. It looks really tiny, but I don't think that's the same answer as any of those that they have.
No, this is the previous problem.
Oh, okay, I see it.
Yeah, this is the one that I'm doing now. This was a problem that was not sent to me via Ask My Instructor.
Oh, okay. I was like,
so okay, so that's why if that's the way the problem was written, then this is the answer. I'm not going to compare it to an Ask My Instructor problem because I don't know if they typed it into the email correct. So that's why I'm just doing it, and that's as is. Because when I get those problems, it scares me to death. When y'all email me something, or when y'all take a picture is okay, but half the time, even though you can see it clear on your camera, on your phones, by the time it gets to me, I can't hardly see it. So the best thing to do is Ask My Instructor. Okay. Next question that was sent to me. I'll pull it up. Because it was sent to me through Ask My Instructor. There it is. This is 3.548/22. And it is really a test question. I'm sorry. T-Rex Community College logs you out every 5 seconds. Mr. Luckner, what is that noise? Sound like
I apologize. I forgot my my mic was on. It's my dog. That's the reason my mic's almost always off.
I thought you were like convulsing on the floor after that last trig problem. All right. So there's the problem. Go ahead and do it. Go ahead and write it down and start. Well, you know it's going to be the quotient rule because it's division. So y is equal to 3 tan t over 2 plus 2 secant t. So if I was to be a good teacher and go ahead and set it up for you, y prime.
You'd be a good teacher if we could see it too.
2 plus 2 secant t denominator times numerator prime.
I don't think you heard me.
What did you say?
I said you'd be a good teacher if we could see it too.
Oh, hold on. There we go. Sorry. Minus. Well, y'all should be able to set it up. I just shouldn't have to set it up for y'all.
I was just trying to be a smart ass. I'm sorry.
That's fine. You were already there. You don't have to try.
You got to speak Marine to get through to them.
Yeah, yeah. There were crayons in your mouth. All right, so that's going to be time. Okay, first denominator times numerator prime minus the numerator. Numerator would be 3 tan t times denominator prime 2 plus 2 secant t over denominator squared. Well, I'm just going to put that right now because you don't need to worry about the denominator squared until at the end. Everybody with me? Everybody okay with that? I'm not going to worry about that. I'm going to worry about the top. All right, so with that being said, go ahead and see what you can do with that. You got to take the derivative here. Take the derivative here. Now, I'm not going to tell you to write everything in terms of sine and cosine this time. What I'm going to tell you to do is look for something, look for another reciprocal. Look for another identity, not reciprocal, but look for another identity to help you. I'll give y'all a minute to do this part. And the black parts are not supposed to change, so I'm just letting y'all know that. Those of you that eat crayons too. You know, when I was in the Marine Corps, we didn't even have any jokes like that about eating crayons. That came after my time. I actually wonder when that started because
If you're not part of the joke, you are the joke.
yeah, that's true.
And back then, eating crayons was serious business.
Yeah. When I was in from 88 to 96. No, 88 to 98. And I don't remember crayon jokes. So it must have been after 98.
Because crayons back then had lead in them.
And that's probably it. That's probably what's wrong with all the old Corps Marines. All right. So y prime is equal to 2 plus 2 secant t. And my peach, 3 secant squared t. And if you see, it's not that big of a deal. I'm going to leave my minus in there for a while. And that's going to give me 3 tan of t. And my peach is going to be 0 plus 2 secant tan. 2, which is 0, plus secant tan.
Mm-hmm.
Now it's Yosemite Sam on. They're going to take his guns away from him, too. Solve the world's problems. Take Yosemite Sam and Elmer Fudd guns away from them, but leave all the blood and guts in Grand Theft Auto. That's okay. Distribute. Oh, I forgot to tell you that the calculus is done here. So all y'all got to do now is just do the algebra. I'll wait for a second and let y'all do that. And you can take this off part 2. That's 0. You don't need it. So you can make that 3 secant go with this, because that's multiplication. 3 times that, and 3 secant times that. You can do that. So y prime is equal to 6 secant t, 6 secant t plus 6 secant cubed t minus this right here is going to be 6 secant tan, and then
Square.
the tan squared, right? Yeah.
Mm-hmm.
6 secant tan squared. There we go. 6, and put a minus in front of it. 6 secant tan squared t. Please check my algebra.
Just go. So far, so good.
Over denominator squared. Now here is where you're looking for something that's, in Sesame Street, one of these things just don't belong here. Remember that something? Remember that game? Well, somebody zero in and tell me what doesn't belong. Come on, come on.
The tangent?
The tangent. We'll color it in that nasty orange color since orange is the new bad color. And y'all picking up on my sarcasm? Y'all hadn't picked up on anything yet. Y'all are very, very.
I have to keep my mic muted so you don't get the laughs. I'm sorry.
Okay. All right. So y prime is equal to 6 secant squared t plus 6 secant cubed t minus 6 secant t times what?
Secant squared t?
Keep going.
Sine squared over cosine squared.
Secant squared minus 1. Secant squared t minus 1.
Fair enough. Pythagorean.
Somebody sees it. Good.
Yeah.
Over. Now you're doing it, and first thing somebody's going to say is, why in the heck are you going to do that? Well, for one thing, you've got everything there, and what is everything in terms of? Secant. There's only one thing out of 7 things there that is not secant. So you should hone in on that tangent and say, well, I need to make everything look like secant. Because there is a relationship between tangent and secant, if you know your identities or if you got them sitting in front of you. Because some of y'all don't know your identities and you need to sit them in front of you. And that's fine. But don't do them without. Please don't do this problem and not have your identities in front of you. Please don't. Because that makes it twice as hard. Y prime is equal to 6 secant squared t plus 6 secant cubed t minus what?
6 secant cubed t.
Oh my gosh, look at there. Plus 6 secant t. Oh my gosh, I can cancel out something. I can take my red pen and I can cancel out those 2 secants. All right, so get ready, go keep going. I'm gonna flip the page and fold it and go to the top so we can keep going. So your next line is going to be y prime equals 6 secant squared t plus 6 secant t over, and I'm going to go ahead and write my denominator is 2 plus 2 secant squared. So of course, the first thing you should see when I write this down is, wait a minute, we may be able to do one more thing here. We may be able to, well, 6 is divisible by 2, so that means I can factor out a 3. I don't know, maybe a 3 secant t? What do y'all think?
It gets better than that.
3 secant t? Take a 3 secant t, y prime is equal to 3 secant t, and that'll leave right here, that'll leave 2 secant plus what?
2.
Oh my gosh, look at here. 2 plus 2 secant t. 2 plus 3 is the same as 3 plus 2, right? So this will cancel with one of these and make that a 1. So your final answer should be 3 secant t over 2 plus 2 secant t. And you should feel good about yourself.
You know what feels even better?
What?
3 over 2 cosine plus 2.
Yeah, I guess you could. I don't know if you could do that or not because of the 3 over 2. I don't know if you could do that or not. No, they didn't do it. I think this is the answer, isn't it? I don't know. Let me look. Well, I can't get my mouse to work. Mouse quit working. The Russians are.
The correct answer is the one that's showing, if you click the red, it'll show whatever the person put.
Well, I can't. There we go.
It'll take a lot of answers.
There it is. Yeah, that's the one in the blue is the right answer. Now, I just want to remind everybody, just to piss you off, and you can't see it because, one, I took it back down, and my freaking mouse.
Priority 1 message coming in on secured channel.
There. Just need to drop it. There we go. What am I going to tell you? The pink is the only calculus. Those are 3 good problems for the test for 3.5. In fact, that's a good number for 3.5 because I'm only going to ask you 1 or 2 questions out of 3.5, not very many. All right, so what are we going over today? We're going over 3.11, related rates, with the time that I have left, which is not much time. What do you have to do with related rates? Well, related rates is not a big deal. Related rates is a lot of plugging and chugging. Now, what's the secret to related rates? Because everybody can plug and chug. Okay? Why is it so difficult? Because you have to know how to do implicit differentiation. Okay? The reason is because we introduced the third variable in related rates, not z. No, we haven't even got to third dimension yet. I said third variable. I didn't say third dimension. Okay? What am I talking about? That magic word called what? The one that we don't have any control over. Even though you do have some mothers that try to control it, and it's not pretty. You ever been to my daughter was in dance recitals and cheerleading competitions. It's really sad. But anyway, implicit differentiation, you have to take the derivative of a function in regards to time a lot. Okay? So I can find the derivative of y to the third in relation to x. That's going to give me 3y squared dy dx. Or you could say y prime. Now, in related rates, you're not going to see the y prime and the s prime and the t prime. You're going to see dy dt or dy dx. Most of the time, you're going to see dy dt. So at this time, I want to take your handy dandy pink highlighter, and you need to make sure that you start writing like that, at least in this section. Okay? What if I've got s to the fourth? And I want to take the derivative of s to the fourth in regards to r. Then that means I'm going to do 4s to the third ds dr. Now, you don't see ds dr very much. I'm just using most of the time when you're learning implicit differentiation, this is what you see all the time. When you're learning related rates, you're going to see dy over dt, dx over dt. That's what you're going to see a lot. But I'm just showing you different. You could take d over dx of x to the fifth, and that's going to be 5x to the fourth dx over dx, which the dx over dx, what does it do? It cancels, so that's why you don't have to put that. And the two that you're going to see the most in this section, what if I want to take the derivative in respect to t of x to the fifth? Well, that's going to be 5x to the fourth d what? Dx dt. What if I want to take the derivative in respect to t of y to the seventh? Then that's going to be 7y to the sixth dy dt. And these two right here are the ones you need to get used to. Because dx dt and dy dt is what we call the related rate.
Which, like, put in physics terms, that's like the x component and y component.
Well, it's like the rate of the weight of water going down in a tank. Dx dt would be, or dy dt, because it's going down.
Yeah. So it'd be like the
be-
y component
Would
rate
be
of change.
5 gallons per second. Something to that effect. For instance, let's say I give you a function f of x, or I'm sorry, x squared plus y squared is equal to 25. Now this doesn't give us anything to do. They don't give us, it's not a word problem. This is not anything to do with, they just give us, they give us dx dy is equal to 7. No units, no anything. And then they say find dy dt when x is equal to 3. Okay, so that's given. All that's given. This is a non-word problem. It is a problem that doesn't have any units on it. So all you're going to do is a little bit of calculus and some algebra. Okay, the first thing you're going to do is you're going to find out what y is equal to when you plug in 3. That's the plugging and chucking. So x is equal to 3. So let's go ahead and find out what y is, because we know x is equal to 3. And if we solve for, and we got this right here, this related rate of dx over dy, so we've got that. So what do we not have? We don't have y, and therefore we don't have dy over dt. That's supposed to be dt, sorry. So these are the two unknowns. So I'm going to take my handy dandy green highlighter. Green means go. We have that, and we have that. What we don't have is these two things. Now, a lot of you are saying, well, why are you doing all this? Because this is your first unit in Calc 2. Okay? Besides the review section, in Calc 2, you're going to be doing related rates and tank problems, work problems. And that's where you're going to be starting off right here. So what I'm telling you is write everything down. You're going to be drawing pictures. You're going to be writing everything down that you have. And some teachers put what you have and what you what? Want. So I don't know, you know, I just put question marks, but some people say have and want. So we can find y real easy. 3 squared plus y squared is equal to 25. 9 plus y squared is equal to 25. Y squared is equal to 15. 16. Y is equal to positive or negative 4. And that goes right here. Positive, negative 4. Now you're going to plug both of those in later. But for right now, you're just trying to find what you don't have. So now I'm done with the simple part because that's just Pythagorean Theorem, and you're done. You're done with that. So that's step 1, finding y in this type of. Now the second step is you're going to be taking the derivative. You're going to be taking the derivative of the first one in respect to t of the formula. Okay, so this is step 2. Take the derivative of x squared plus y squared equals 25 in respect to t. So that means everywhere I take a derivative, if it doesn't have a t in it, I've got to make it t prime or dt over dx, dx over dt, or dy over dt. So here we go. 2x dx over dt plus 2y dy over dt equals 0. Now, at this point, you say to yourself, wait a minute, I've seen a lot of this before. Yes, you have. You've got x, you've got y, and you've got what? Dx dt. So what are you going to do? Plug and chug. Go ahead and plug and chug. 2x dx dt, 2y, 0 is there, so solve for whatever you need to solve for. I'm going to go ahead and plug and chug. So 2 parentheses, what's my x? 3. My dx dt is 7 plus 2 times 4. I'm going to put in a plus 4 or a minus 4 first, or a plus 4. I'm going to put in plus 4. Okay? And then dy dx and that's going to give me blah, blah. I'm basically going to give me 21 over 4. So I'm just going to go.
So wait, why'd you do the dy dx? Because it's dy dt, right? On the other one.
Okay.
So that would
So
be
that's going to
7.
come out to be dy dt is equal to, I got negative 21 over 4.
And 21 over 4.
I'm sorry, what?
Positive and negative version of that.
Basically, you're going to get the same thing. Yes, you're going to get 21 over 4. Because if you solve this for dy dt, if you solve it and plug and chug, you're going to get the same thing. If you go up here and you do dy dt is equal to negative x dx dt over y, and you plug in, let's see, negative 3, 7, and negative 4, you're going to get 21 fourths. And that's plugging in the negative 4.
Yeah, where did the negative 3 come from? That
The
The
X
x
3.
up there.
okay,
What's
well,
x?
where did the negative x come from?
Where's the x? What's x?
Is just 3.
Okay. When you solve for dy dt, when you solve this for dy dt, you're going to get the negative x when you bring it over.
Okay, gotcha. All right. Yep.
Because you divide by 2, you got to bring it negative x over.
Okay.
Solving it. Or you could pretty much plug what you don't have down here and solve it. I don't care about that. You're going to get 21 fourths no matter what. You're going to get negative with the positive 4. You're going to get positive with the negative 4. Now remember, this is not a word problem. So you can't say, oh, 21 fourths is how much. It's not a word problem. They're not asking you for it. This is just a literal, just a algebraic rate of change. You use the derivative right here.
So if it were a word problem and it was asking you to solve t for time, you'd use the positive one because time can't be
Yes,
negative.
of course, or distance.
Okay.
Yes, that's what we're fixing to do. And of course, we don't have 10 minutes, but I expected that. So we're okay because I'm not through with the unit because I still got to cover. Hyperbolic, which is Koch, and I ain't gonna even worry about that. This problem, they give you the area. Oh gosh, I didn't write the daggum sentence down. Oh, shoot. Okay, I'm gonna skip this one right now. because I don't have the question written down. This one talks about two boats. Okay, you got a boat heading west and a boat heading south. Boat heading west from port and a boat heading south from port. And the boat A is heading west. It's going at 20 miles per hour. And the boat B heading south is at 15 miles per hour. And they're wanting to know how far the boats are spreading out versus on the diagonal is what they're wanting to know. You'll see in just a second. You got to draw a picture. So let's draw a picture. Here's the port. You got one boat heading west and one boat heading south. The one boat heading west is at 20 miles per hour. The one heading south is at 15 miles per hour. We'll say this is B. And this is A. This is port. Now we know that this diagonal is going to have some distance relation to it. We're going to call that L. And that's what they're trying to find. Well, at what rate is that distance increasing? Because they're going in, this is going in this direction. They're 90 degrees apart, so they know they're going away from each other. Okay? Or 180 degrees apart, or whatever the case may be. They're not going in the same direction. Well, the first thing to write down is L squared is equal to x squared plus y squared. Okay, that's the first thing to write down because that's basically going to give you your L. And if we take that derivative, you take that derivative in respect to t, you're going to be getting dl dt. Okay? Now, what is the derivative of L to the second power? 2L. So that's going to be 2L. I'm going to put L in uppercase. And that's going to be dl dt plus equals, I'm going to put an arrow right here because I don't want you to think that this is equal to that. Okay, so to find dl dt, first thing we got to do is take the derivative of this in respect to t. And then we're going to solve for dl dt. Okay, so that's going to be 2x dx dt plus 2y dy dt. Now solve for dl dt. And you're going to get dl dt is equal to, I got x dx dt plus y dy dt over big L. You don't check me, but I believe that's what I got.
Mm-hmm.
Now you need to put that in a, well, we need to find the dx dt and the dy dt and the L. So we're going to leave that for right now We're going to put a cloud around that because we're going to come back to it. Because I'll put down what we have. Right now we have, I'm going to put green. We have dx dt. Dx dt is 20 miles per hour. dy dt is what?
15.
Now we just got to know the distance of the remaining of 3 sides. I want y'all to do that. I need to know, x. I need to know y, and I need to know L. I'll wait for y'all to do that. Oh, did I mention that we were done with the calculus? Here's the calculus. So find those 3 distances. I'll wait. Oops. Need to hurry. I don't want any of y'all, spontaneously combusting. Mr. Luckner may start burning up. Okay, can somebody tell me how to get y and x? Okay, I left out one thing. I'm sorry. I messed up. I should have told you at a half an hour. I'm sorry. I wish I could copy all these dadgum questions down, but I can't write all that. I'm sorry. A half an hour. So that means you can change this into a distance, and you can change this into a distance, because what is distance? Distance equals what? Rate times time. So if you've got a half an hour, how far did you travel in 20 miles per hour? How far did you travel in a half an hour?
10 miles.
And for 15, how far did you travel in 15?
7.5.
And somebody do the Pythagorean Theorem for me. 12.5. Now somebody tell me, what are you going to do with those 3 numbers and the numbers that you already got?
Plug and chug.
Plug and chug into your calculus that you did right here. Again, you're talking about your first test in Calc 2. So you better have your ducks in a row. All right, so here we go. So dl dt of times and distances that we have. We have x now, that's 10, times 20, plus 7.5 times 15, all over 12.5. Somebody crank that out. I got 25 miles per hour, but y'all check me. And if you get that, that basically is the rate that the boats are going away from each other. The rate the boats are moving away from each other. Away from each other. Now, it's very important that you understand what this means, because this is a two-dimensional drawing. You've got 4 things that were given to you, or 2 or 3 things that were given to you. You got, well, one that was given a little bit too late, but 20 miles per hour, that's something you can do every day. 15 miles per hour, you'll travel in the car every day, or a bicycle. Time, and you have a destination. I mean, you have a origination and a destination, or a direction. If you take those directions and those dates, you can actually figure how much you and somebody else are going apart from each other. Now, all this plays into effect with the same principle as a point in what? Point in space. That's what your goal is. Your goal, by the time you get through with Calc 1, 2, and 3 and Physics 1, 2, and 3, be able to tell us about anything pertaining to a point in space, in 3-dimensional space. That's where we're heading. Okay? So, how does that make you feel?
Wonderful.
You feel like you can impress somebody, right?
This
Go out to your local bar and impress your friends.
I feel like this is all way too much work.